Hi, so I'm Shantanu Tamali. So today I'm going to discuss about how to do the uh, two-way ANOVA. Okay, so now there are different types of two-way ANOVA. So one is the two-factor ANOVA, where you have two factors. Now the ANOVA which we are going to discuss. So in this case, you have multiple groups. Okay, and then you have taken the observations, or you have taken some kind of readings in different occasions. So for example, uh, you have suppose 7 groups. Now in 7 groups of individuals, you have measured the readings in 3 different days, say day 0, day 7, and day 14. Okay, so now here the analysis which you have to do is whether the 7 groups are different in day 0, day 7, and day 14. Number one. Number two, whether a particular group, okay, the values of the particular or the mean of a particular group varies from day 0 to day 7 to day 14. That means, is there any difference between different days? Number one. Number two, is there any difference between different groups? So this kind of ANOVA, it is also called mixed ANOVA, that is within group and between group ANOVA. So within group means within a group you will see whether the mean values in different time interval is different or not. Then between group is within a particular day, say day 0, whether the group 1 is different from group 2, group 2 is different from group 3 or not. So these things you will see in the between group analysis. So we will see how to do this analysis in the R software. So we'll be doing the mixed ANOVA, okay, and then we'll go for the post hoc ANOVA. That is, we'll be using the Bonferroni method. We'll use the pairwise t-test followed by Bonferroni correction. So this we'll do in 2 ways. So one is for between groups in a particular day, and second is in a particular group between different time intervals. So let's go ahead. We'll open the R software. So this is our two-way data. So these are the groups. So GR1, GR2, all these groups are arranged in this manner in the Excel. Then this is the day 0. Actually, this is I've written it as day O. Actually, it should be read as day 0 because 0 sometimes it is not accepted by the R. So this day 7, day 14, day 21, and this is the ID values I have given to all the individuals. Okay, so now we open the R script now. So here, first of all, we'll have to load our data. So to load our data, we use the read.table function, and then we open the Excel sheet and we copy the data. Thereafter, just press enter, and we can see the first few rows of the data. So this is the first 6 rows of the data: day 0, day 7, day 14, day 21. This is the ID. Okay, now the next thing is we'll have to convert this into long form. So for this, we'll have to use the library of Tidyverse. We'll have to load the package Tidyverse. Okay, so after loading this package, now we use this data1. We just name the new long form of the data as data1. Data1 is equal to data. This is our original data. Then this is the pivot operator. Then we use the gather function. Then key is equal to, so I just named the number of days as key only. Then next is, oh, I'm sorry. So key, after key, let me remove everything. Okay. data 1. This is the new data 1. I have named the long form of the data equal to data, my original data, then pipe operator, then I use the gather function, and then I just name the number of days as key just for this example. Then the values in the different days, I just name it as value only. Value is equal to, I name it as values. Then thereafter I just say 2 to 5. That means here the number of columns I need to stack. So if we just look into the Excel sheet, so here our columns that are to be stacked are these columns: day 0, day 7, day 14, and day 21. So this is the second column. This is second column, this is third column, this is fourth column, this is fifth column. So second to fifth column. That's why just write here second to fifth column. And then I put another pipe operator, and then convert as factor groups, comma id, comma key. So the groups that I have, all these variables, they will be taken as factor variable. Oh, I'm sorry. Actually here I just put convert as factor, then groups id and key. Yeah. So if we just look into the first few rows of the data 1, so here you can see that all the data has been stacked in this manner. So all the days has been put under key, and all the values has been put under the variable values. Okay, now thereafter we'll proceed for calculation of the mean plus minus standard deviation. So for this, I'm going to use this function. So here I just name it as mean SD. So I'm putting it as a mean SD. So this is just the name of the variable. Then in the data 1, then group by key. So I'm grouping them by days, and then next grouping will be done by as per the groups. Then I'm using the summarize command. So summarize this capital mean is equal to round mean values, comma 4. So round means it will be rounded, and I'll take the mean values, mean of these values. Okay, then comma 4 means it will give me the decimal point up to 4. Then standard deviation, the same thing is here. Standard deviation is equal to standard SD values, comma 4. And here also I'm putting the round, it will be rounded to 4 digits. Okay, now we have done it. Okay, so if we just see, so this is the way it is showing, but this is not, in this way, in this form, you cannot put it for the publication. So for publication, we have to put it as mean plus minus standard deviation. So for this, we can use some other advanced methods. So here I'm just naming a new variable, that is mean SD1. So here mean SD pipe operator, I'm uniting mean SD, then mean, then the mean and SD will be here. The mean and SD will be united. Okay, and this united, the new variable will be called as mean SD, and it will be separated by this particular sign plus minus. So if you see mean SD1, so here this is the mean and this is the plus minus SD. This is the way how we put it in the for publication. But again, here in the tabular form, this is not in proper form. So again, we just because it is in a long form. If you see the mean and standard deviation, it is a long form. So we will convert it to the it will convert it to the wide form. So for this, we will use the spread function. This is the, so we just name it a new variable mean st2, then we use the mean st1 as earlier. This is the pipe operator, group by keys groups. Okay, then spread, key is equal to key and value is equal to mean st. So if I just see, and you can just see mean sd2. So this is the proper way. This is the day 0. Of course, day 0 should have been here, so we can just adjust it. Now we will copy all these things into the Excel using the write.csv command. Mean sd2, then under quotation clipboard, clipboard. Okay, now just go to Excel sheet. So in the Excel, we'll just go down here. I'll just paste it, but when you paste it, it will come in this way. So what we can do now, so just go to the data. So in the data, you will find here text to columns. Click in the text to columns. Okay, then next, so here you check the comma and finish. So now what you can see is that this data has been put in the nice tabular form. Okay, this is the way how you are to present for publication. Now here the day 0 should have been come here, so we can just rearrange it as it should be. Day 14 I put it here, day 0 I bring it here, then day 21 here, day 14, then day 7 here, and day 14 here. Okay, actually these things we can also do by using the set level command. So this I'll show you later on. I'll just show it in the description box how to adjust these levels, so we will not go for that. Okay, so now we go back to our R. Okay, so this commands we can use it for calculating mean and standard deviation. So similarly, same thing we can do is for mean plus minus standard error, same way. So the standard error, just show it very quickly because time is somewhat less. Okay, so here the first one, then thereafter, so in this case what you have seen is that SE is equal to standard deviation of values, then square root of the length of values. So this is how we calculate the standard error. So I'll show you, I'll put this codes in the description, you don't have to worry about it. Okay, and then thereafter we just the same way we can go. Yeah, there is a, so here okay, so SC2, just put it over here. Yeah, so this way it has made. This is for mean plus minus standard error. Okay, then that's all about the reporting of the data. Now we'll proceed for the two-way ANOVA, which is our main topic of discussion. So again, we open the Excel sheet. So this is the data. Now we'll enter this data for two-way ANOVA. So for this, we'll open the R script. Now to carry out the two-way ANOVA, we'll have to load some packages. So the first package we load is library tidyve tidyverse. Then the second package to be loaded is the R statics. Then the third package to be loaded is the library, then broom package. Then the next is we have to do is make title package. Okay, then thereafter the next we have to use is R companion. Okay, that's all the packages need to be loaded. Now what I'll do is that I'll use the my data command, again read dot table the same way. So here I'll copy this data once again. Okay, so now enter, then add my data. So these are the again same way as we have done it earlier. Now the next is we'll have to convert this data into the long form as earlier we have done. So we'll do it in the same way. So I have just I have named it as my data only. So if I just see the first few 6 rows, so you can see on this particular data it has been converted to long form. Okay, so here the days have been named as time and the values have been named as score, as I have shown it, as I have put it in the commands, score and time. Okay, now we can see the outliers. If we have any outliers in the data, we can see here. So to see the outliers, you can use this function of identify outliers. So group by time and groups. Okay, so you can see that here there is a is dot outlier. Yes, outliers are there, but is dot extreme outliers, you can see it's not there. Majority of them are free from extreme outliers, so there is no problem in my data. I don't have to remove any data. Okay, then next is we can carry out the Shapiro-Wilk normality test to see if the data is normally distributed or not. So for this we use the Shapiro test and score. Score is the response variable. I am grouping same way. I am grouping by time and then group. So here you can see this is the we have to see the p-value. The p-value should be more than 0.05. So majority of the p-value is more than 0.05, but you can see that here 18 rows have not been shown in the R console. So for this reason, what we can do is that we can repeat the command that we have given earlier. We just repeat the command and we name this as S. So now our Shapiro-Wilk normality test, the result is named as S. Now we'll just copy it to Excel. Copy to Excel. Okay, S, then clipboard. So just open the Excel sheet, come down. Okay, you can paste it. So here, because once we have done this data manipulation, and we have just asked the Excel to consider it as a table. So second time when you will paste it, you don't have to do the same thing, because once if it is closed and you open it once again, in that case only you'll have to do that as I have done earlier. But since I have already done, so till this Excel file is open, you can just directly paste it. So here you can see this is the report of the Shapiro normality test. So here in majority of the cases you can see the group 1 in day 14, group 2 in day 14, and then I can say group 1 in day 21. So here all the data that is more than 0.05. Few data is less than 0.05, but majority of them are more than 0.05. So this is suitable for ANOVA. Okay, now we can also see the ggqplot. So to ggqplot I'm using. Okay, before that we must load the package called ggpubr. So I load this package. Okay, fine. Now ggqplot my data, then score is the response variable which I'm having. Okay, then face set, you can see if I just press enter. Okay, so this is, you can see here most of the dots, they are in the line. These are my different groups. Okay, and these are the different days. Okay, so there is no issue with this. So these are the different days and these are the different groups. So there is no problem. So I can now, I'm sure that my data is normally distributed. I can surely go for ANOVA. Okay. Now I will directly go for ANOVA. So for ANOVA, I'll use the AOV function that is present in the base package. This is the AOV function, score versus group times time plus error. Now inside the parenthesis I have put the ID. So ID is the variable, that is the ID of individual in each and every group. So this is under error. Okay, so I'll just name this ANOVA as AOVM. Okay, now let me see the summary. Okay, so you can see here this groups. So here all the groups are significantly, groups have significant difference. I mean, at least one group is significantly different, and same is the time. So if you can see the time here, so time is also significantly different. That means at least few groups there is the difference between different time period exists. Okay, now we can proceed for the post hoc analysis. So for post hoc analysis, we'll use the pairwise t-test along with the Bonferroni correction. Okay. Now we just let me remove all these things. So here this is the my data. Okay, I'm group. So we are okay. Let me tell you one thing, that we'll have to do the pairwise comparison two ways. First is between different groups in a particular time, and second is between different time in a particular group. So first of all, we will do the pairwise comparison in different groups in a particular time. So since we are doing it in different groups, we are seeing the difference in different groups, okay, within a particular time. So that is why we are grouping it by time. So we call it a group by time. So this one is pairwise comparison between different groups in a particular time. So we are grouping it by time. So here score versus groups. Okay, then p dot adjust method, p value adjustment method is Bonferroni. Okay, we are just naming it as a PWC, pairwise comparison. Okay, so now we cannot see the PWC. If we see over here, it will be difficult. So what we can do is that we can paste this PWC object into the Excel using the write.csv, then PWC, then clipboard function. And now I open the Excel. Okay, so this is the thing that we have got. Okay, so you can see this is the time, it is grouped by time. Then this day 14, group 1 and group 2 difference, day 14 again, group 1 and group 3 difference, group 2 and group 3, like this. Then again you can just go down, day 21, group 2 and group 1 and group 2, group 1 and group 3. So this way, based on different times, these groups are differentiated. And if we just go this way, this is the p adjustment significance, I mean this one. So this one, we have two p value, one is this one and one is this one. This one is the t-test p value and this one is the p value we have obtained after Bonferroni correction. Okay, now what we'll have to do, so we will have to copy this. Suppose first of all we are seeing the difference between different groups within a days. Okay, now in order to put it in for publication, we'll have to put some alphabets, compact letter display over the mean. So for that, how we will do, we'll first proceed for that. We'll just copy all the data in the day 14. So while copying this, we will see that all the data of day 14 are copied, and from 1 to this 21, all the day 14 are copied, and not to copy this header. So we copy this. Okay, so after copying this, we just go to R program here. So in the R, we just paste the command. So now to, oh, I'm sorry. So now in the R, what I will do is, so I'll use this command read.table. So only clipboard I'm using. So let me copy this once again. Okay, so if I just see the head of the, I mean few rows of the PWC COMP. So these are the things which I have copied from here. That means this is the data of the day 14 only. So now for comparison, what we'll have to do, we'll have to use the CLD function, I mean compact letter display function of the R companion. So for this, we'll have to join these two columns, V4 and V5. So for this, we will use the unite function. So in the unite function, this is PWC is our data, then this is the unite function, then treatments. So that means these two, when they will be combined, so they will be, the combined column will be named as treatments. So which columns to be combined? V4 and V5. So this V4 and V5 will be combined and using the SAP, and they will be separated by this hyphen. So remove is equal to false. Okay, now just, okay, now we see the header function. Now what you find here is that this is V1 as earlier, but here we got a new column, that is the treatments. So here GR1 and GR2, there is a hyphen is there. This is required for CLD function. Okay, so now we proceed for the CLD function now. So for CLD function, So you can see the V10. If I just repeat the earlier command, so you can see that V10 is basically the p dot adjust. That means in Excel file, this column is the V10. This one. This column is the V10. That is p adjusted value through Bonferroni. Okay, this is the V10 we have taken here during CLD, and then versus treatment data is PWCC-OMP. Okay, so let me remove this and repeat this. Yeah, so here what you find is that in the day 14, okay, GR1, the mean value of the GR1 over the mean value of the GR1, you have to put A. Over the mean value of GR2, you have to put B. And over the mean value of GR3, you have to put C. Likewise. Okay, and in this group 6 and group 7, they are not different. That's why their letters are same, F. Okay, so again we can repeat the same thing for okay, so this one we did for day 14, though, so same way we can repeat it for day 21 also. So I can show you once again. So I copy this, then I'm required to paste it over here. Okay, and then in the same way I will go for uniting. I have united, and then I will go for CLD function, and this is the way. This is for the earlier one was for group 14 and day 14. Now this is for day 21. So likewise you'll have to do for all the days. This way you can do. Okay, so this is about the difference between the different groups in a particular day. Now I'm going to show you the difference between different time interval within a group. So in this case, earlier we grouped the variable by time. Now we are to group it by group. So group by group. Okay, so now our aim is to find out the effect of time at each level of groups. Okay, so we just remove it, and okay, so here we are naming it, earlier we named it as PWC, now we are naming it as PWC2. Okay, this is my data. Then now earlier we grouped by time, right now we are grouping it by groups. Okay, then pairwise t-test, then score versus time. Earlier it was score versus group, but now it is score versus time. Okay, then paired is equal to true. So this is this extra argument is added over here, because here we are analyzing the effect of different time interval in a same group. So that is why it is a kind of paired t-test. That is why we have written as a paired is equal to true, because it is a pairwise t-test. Okay, fine. Now we can paste this in Excel. CSV PWC2, then clipboard. Okay, let's go to Excel. We can paste it here in Excel. Yeah, we have pasted. So this column is the p-value adjusted through Bonferroni. Okay, so here you can see this is they are grouped as groups. So this is group 1, day 14 and day 21. What is the difference? Difference is, you can see in group 1, day 14 and day 21, there is no difference, and as you can see here it is more than 0.05. then in the same group the 7 and 14 they are different. Okay, is the statistically significant differences there, but now it is difficult to see in this way. So what we will do, again we'll go for the compact letter display system. So we will copy up to here all the group 1 and then just copy, then come to our console. Okay, yeah, we have copied, and we can see so this is the data we have copied for group 1. Okay, so now the same thing is here in this position. Now we'll have to merge v4 and v5. So we merge it, v4 and v5. So here there can be issue because day 14, already day and 14 we have put the hyphen, so we'll have to remove this hyphen for this purpose. So but we can just go back to Excel. So remember that in the day and this number you should not have the hyphen, so I put the hyphen here. So simply in the Excel function, replace, I'll just put hyphen as underscore, so there won't be any problem. Okay, so all okay. So now I'll just repeat this once again, copy it. So after copying, just repeat the things. Yeah, okay, yeah, that's great. Okay, so now we'll have to merge these two columns, v4 and v5. So again we'll have to use the unite command. So now we are using the unite command, and v4 and v5 they will be combined, and the combined rows, combined columns will be called as groups. I'm just naming it as groups, and they will be separated by hyphen. Okay, now so this is the new variable groups. So here new column, so you can see the day 14 and day 21 versus like this it is written. Okay, now the next we can go for the compact letter display using the CLD function. So this is the CLD function. Okay, CLD, then here this value v11, it is so v11 is or v11, this particular column is a p value or adjusted p value. So we'll have to compare these groups with the adjusted p value. So v11, I have written it here, v11, then versus groups. So when I just put it, yeah, so in the average value in the group 1, okay, because we are just talking about the group 1. So in the group 1, the average value over day 14, okay, it should be number as A. Then if you see that in the group 1, this 14 and 21 they are not different, having the same letter. Then day 7 and day 0 they are different, B and C, and day 7 is also different from these two. Okay, so this way we do it for group 1. Again we can just show it to I'll do it in the group 2 also in the same way. So let me copy from group 2. Okay, so here again the PwC2 comp as a new vector I'm using, as earlier I have used, because earlier I have used PWC-COMP. Now I'm using PWC2-COMP comparison. Okay. Okay. So it has been copied. So this is the one. Again, same way, this V4 and V5 will be united. So to unite this, I use the unite function, same way as I did earlier. So you can just check. Yes, it is united under the new column with heading groups. Now I go for the CLD function in the same way. Okay, so now for group 2, the 0 and 7 they are different, but 14 and 21 they are not different. AA it is there. Okay, so this is how we do the two-way ANOVA multiple. Then after two-way ANOVA, I mean mixed ANOVA, between group and within group ANOVA, then we proceed for this post hoc comparison through pairwise t-test using Bonferroni correction, and lastly we use the compact letter display to show the significant difference. Thank you very much for viewing this video. If you like this video, please press like button. Thank you very much.